Hi everyone. Today's video is about the antiderivative of trigonometric functions. Before we start, let me just remind you of these two things. So number one, it is very important that you have a good foundational knowledge of trigonometric identities because in some cases you need to simplify trigonometric expressions that are given. Now, number two is also you need to be familiarized with the equivalent integrals of trigonometric functions. Now, to help you with that, in number one, for example, you will see the antiderivative equivalents that we will use in every example that I will give you. So for number one, we have the integral of cosine x minus sine x dx. Those are the two that we will be using on the upper right side. So let's solve number one. This is equal to cosine x dx minus sine x dx. Now, as you can see on the upper right, cosine x is equal to sine x, antiderivative of that. And then also the sine x is equivalent to negative cosine x. But we have a minus sign here. So that's minus negative cosine x. So that negates each other, which means this is going to be positive. Cosine x plus c. Oh, there you go. That's our number one. Let's go to number two now. So sine x over cosine square x, like what I mentioned earlier, familiarity with identities is very important in this lesson. So since I already showed you the formula that we will use, what I'm gonna do or the objective is actually to reach that point, right? So how can we convert that sine x over cosine square x into that one? So what I'm gonna do here is separate that cosine square x, the denominator. So I can write that as this one, right? Now we all know that sine x over cosine or sine over cosine is tangent. And then 1 over cosine is secant. And there you go. According to our formula, this is equivalent to just secant x dx. There you go. Okay, so let's go to number 3 now. Let's simplify first the expression that we have here. 1 over cosine is secant square x dx, and then minus 1 over sine is cosecant square x dx. So secant square x dx is equal to tangent x, and then cosecant is equivalent to negative cotangent x. So that's negative. There's a minus sign here, and that's also negative. So that means this will be equal to plus c. Alrighty. All right, let's go to the next one. Number 4, tangent raised to 3x dx. So tangent x dx is equivalent to ln of secant x plus c. There's actually another equivalent of that involves cosine function, but I prefer using this one. So what I'm gonna do first here is I will separate that tangent x from tangent cube x. So meaning I will factorize this one. So tangent square x times tangent x dx. I'm going to use some trigonometric equivalence here. Tangent square x, we understand that that's equivalent to secant square x minus 1, right? Then tangent x. And then I will multiply the tangent x to secant square x and that negative 1. So this will be equal to tangent x secant square x minus dx minus Tangent minus 1 is tangent x. Now, we already know the tangent x, that's equivalent to the one on top. But let me just tell you something. The tangent x, secant x, or secant square x, if we want to go back to our lesson about um, the derivatives, so if you want to find the derivative of d over dx tangent square x, this is just a reminder, by the way. So the derivative of this is using the chain rule. This will be 2 tangent x secant square x. So as you can see, that's almost similar, right? There's just a 2 here. So the antiderivative of that will just be 1/2 of this tangent um, square x. And of course, the antiderivative of tangent, which is given on the upper right side of your screen, that's ln of secant, absolute value of secant x plus c. Oh, what happened? There you go. Let's go to example number 5. Rather, we are halfway through our lesson today. I have 10 examples here. So 1 over cosecant square x minus 1 over cosecant square x. Okay, let's try to simplify this first. So 1 over cosecant square x over cosecant square x minus 1 over cosecant square x. Okay, so this is just 1. That's equivalent to sine. So 1 over 1 minus sine square x. And we know the equivalent of 1 minus sine square x, right? That's cosine. So 1 over cosine square x. And that's equivalent to, so this is just secant square x dx, which is equivalent to what we have there on top, tangent x plus c, right? All right, let's go to example number 6 now. So tangent x minus cosine x plus sine 3x. This is straightforward. We have the three formulas that we will be using here. So the first is tangent. That's ln of secant x, right? Cosine is sine, so this is just minus sine x. And then finally, the last one, sine 3x. So take note of that. That's the general form of that is sine ax, and according to our formula here on the right side, that will be equivalent to minus 1/3 cosine 3x, and of course the plus c. Right? It looks kind of, oh, this is number 6. This is going to be difficult, but no, it's a lot easier, I think, than the previous 3. All right, let's go to example number 7 now. And I think this is also straightforward. As you can see on the right side, we have those equivalents. If in general form, we have a sine ax dx and then cosine ax dx. All right, so let's go straight to our answer. Sine ax dx, or let's use the cos. Let's solve the cosine first. This will be 1 over 3 sine 3x, and then minus 1 over 4 cosine 4x. And we all know that the antiderivative of 1 is just x, so plus c. Alrighty. Okay, let's go to the number 8. Okay, so cosine x plus pi over 3. This is again an example of something that we need to simplify first. So this is sum and difference identity of cosine function, but this is sum to be specific. So this is similar to, just to remind you about that identity. So cosine A plus B is equal to cosine A cosine B minus sine A cosine B. Alrighty? So to apply that formula or identity rather in our problem, this is going to be equal to cosine x cosine pi over 3, okay, dx minus sine x sine pi over 3 dx. All right, cosine pi over 3 has an exact value, so you got to think about that. What is the equivalent of cosine pi over 3? I believe that's 1/2. 1/2. So I will put that 1/2 outside. And then what about sine pi over 3? That's square root of 3 over 2. Let's put that outside. And there you go. So this is just 1/2 cosine x is sine x minus, and this is going to be plus because the equivalent of sine x dx is negative cosine x plus c. But we need to include that square root of 3 over 2. And that is going to be our final answer. All right. Let's go to problem number 9, or example number 9 rather. So cosine over 1 minus cosine square x. Okay. Let's again simplify the trigonometric expression here. So I think we can write this as cosine x over sine square x. And then I think we can separate that sine square x. We can have um, cosine x over sine x times 1 over sine x, right? Cosine over sine is cotangent x, and then 1 over sine is cosecant x. So which means this is just equivalent to cotangent x times cosecant x dx. And then as you can see in the formula on top, that's just equivalent to negative cosecant x plus c. All right. We are now down to our last example, and we will be using the identity on top, or the formula on top. Secant x tangent x dx is equivalent to secant x. So how are we going to do that? Okay, let's multiply the binomials on top. So that's 1 minus cosine square x, and in the denominator that's 1 minus sine square x. And of course we know that 1, okay, don't forget that cosecant x, by the way. 1 minus cosine square x is just sine square x, and this is cosine square x. So minus, let's do this, 1 over sine x. Okay. And now we can simplify or cancel out the sine. That will leave us with 1 sine x. So what I'm going to do is I will separate that cosine square x in the denominator. I'll put the 1 cosine x here, and I'll put the other cosine x on the other under that 1. Okay. So that means this is just equal to sine x over cosine x is just tangent x. Then 1 over cosine is just secant x. And that's our formula on top. This is just equivalent to secant x dx.